Okay, guys, in preparation test, which everybody should do really well on if you video, we're going to go ahead and look at this. Now, first 9 questions, this is just all about pivoting, okay? And I'm going to be a good student, and I'm going to write my work on another sheet of paper because there is really hardly any room to write on this part. Okay, next kind, talk about taking the derivative of, we're just using power rule, okay? 4 comes down in front, that's 6. This is plus 1x. We know the derivative of that is 1. We know derivative of 0. Okay, make sure that you write f prime of x so we know what it is we're talking about. Okay. Now we know that the power rule works even if we have fraction exponents or negative exponents. Okay, it always works. Here's what this looks like. Okay, if I bring that down, that's 1/3 x to the, and then when I subtract 1, negative 2. I bring that down, that's positive 1/3 x to the. I subtract 1, that is negative 4. Usually my rule of thumb is if it started off by giving me negative fractional exponents, I could just leave. Okay, you don't have to move them down to the. Okay, now a lot of these problems are going to test you on if you know the easiest way to do this. Okay, now you could decide to do this probably not the easiest way, but you could do it that way. Show you. You would go low d high, that means true to the high, true to the one on top, minus high d low, that's 12t squared, square the bottom, and away you go. But I'm pretty sure that this question on the test does ask you to give a simplified answer. Okay, now check it out. We know that that goes to 0. So this is going to give me negative 36t squared, and this is going to give me 4 squared 16t to the 6th. Not very simple. So I could probably simplify that. What goes into 36 and 16? 4 would go in 9 times and 4 times. Yeah, 4 goes in. So 9 over 4. And then I would cancel out. So there's a t to the 4. Okay? That's how I can get it with quotient rule with simplifying it. But there's an easier way to do this problem. The easier way is just to rewrite this to say, okay, so first of all, keep the numbers the same, still 3/4. But we bring the t to the up and write it as t negative. And now we can do a power rule. Right? Power rule, negative, so 3 times negative 3 is negative 9 over 4, t to the negative 4th. Okay, I can leave my answer like that, or I can write it negative 9 over 4 with a t to the 4th. Okay, and if you look, that was like clearly a much faster way of getting to this exact same. Okay, you can use quotient rule. Me personally, I will only use the quotient rule if there is a variable in both the top and the bottom part. So like I'm going to use it on number 4, I'm going to use it on number 6. Number 7, I think I can maybe simplify it first, so I don't have to. Okay? All right, here we go. Okay, number 4 says tangent of t over t. Okay. Now, this we are definitely going to use. What you need to remember for this problem is that the derivative of tangent is secant squared. Okay, so that's a derivative that we have learned, derivative of tangent. Okay, so I get low d high, so t times secant squared, minus I d low for the bottom, and away you. Now, nothing can cancel out here. Remember, you have to cancel this unless there's one over here. Be careful about too much. This is basically my answer. Okay, it doesn't have to have the times one in there. We can get that, but this is all right. We just do it. All right, let's get down a little more. All right. Okay, h of theta is 2 theta cosine theta minus sine theta. Now we can do this as two different um, derivatives, okay? This is one, this is the second. However, on this first derivative, you actually have to product here because theta is my variable. And so it would be like saying, I do need a product rule. My product rule goes derivative of the first times the second. And then first times derivative of cosine is negative sine. Okay, that was like just that part. Now I'm going to do this, and it's going to be minus and the derivative. Okay. So what I'm going to do is negative to negative. Okay, and if it's an FRQ, I would just leave it like that. You know, if it's a multiple choice, they might reduce this. You might notice that that reduces if you had to reduce cosine theta minus 2 theta sine. Okay? All right, perfect. Let's take a look at number 6, f of x, negative 2x squared over x1. This is definitely, does not simplify at all. Okay, so my derivative, low d high, when that comes down, that's my x, minus high d low, the derivative of the bottom is 1, square the bottom and away you go. Now, a lot of times on a quotient rule, we are going to be asked to simplify it because things simplify a lot on quotient. Like if I distribute that, I get negative 4x squared minus 4x. And then this is just multiplying a negative times negative is positive. That's positive squared. Okay. Which means I can write this as, if I combine these terms, negative 4x squared, negative 2x squared over x. That's a perfectly fine way to write. Nothing cancels out. If you wanted to factor out a negative 2x, you could. Again, if you were on a multiple choice part, okay? But like on an FRQ, we just leave it there. A multiple choice one, right? Perfect. Okay. Now, anytime you can simplify a problem before you start, always going to make for an easier derivative. what we can see right here, you guys, is if, both of them cancel by an x squared, I can reduce this down. In fact, what I'm really doing is let's divide this one by x squared and 2, right? Okay, right here, x to the third divided by x squared is x. Here, x divided by x squared is 1. This is just y equals x minus 1. So what's the derivative of that? Well, the derivative of 1x is 1, and the derivative of 1, here, I get it. All right, guys, every so often I go and check to make sure I've done anything wrong. I realize I wrote exponent on number 1. A bunch of you probably already found that out. Give yourselves a pat on the back. Okay, that was supposed to be 3x to the third. I wrote 3x squared. Anyway, that makes my derivative minus 9x squared, and then, okay? But other than that, the rest of them were right. So, yay for me. All right, let's take a look. Okay, now the way it stands right now, we cannot do this problem without rewriting, right? There's a rule that we're going to learn in REAP where we will know how to do this without multiplying it out. Right now, we don't. We have to rewrite this as 2 minus 3x times 2 is 3. Now, you actually could go from there and do a product rule. I'll show you guys what that looks like. Negative 3 is a constant. It just stays out front. We'll do it like that, right? And we go derivative of the times the second. And then plus the derivative of the second times the first. I'm not giving myself a times the first. Do a product like that. When I distribute everything, that's like negative 6 plus 9x, that's negative 6 plus 9x, which is negative 12 plus 18x. And if I multiply all that by negative 3, I get positive 36 minus 50. Okay? That's one way to do that as a product rule. The other way we can do it, I'm actually going to just do it right above, is I can multiply that out. All right? So I would get negative 3 times. Now, if I FOIL this right now, I get 4. Outside and inside give me minus 6, and minus 6 would be minus 12x plus 9x squared. If I distribute through the negative 3, I get negative 12 plus 36x minus 18x squared. Okay. Now, if I take the derivative, that goes away. I get 36 minus 18 times 2 is 36x. So, clearly I screwed up somewhere. Okay, so let's see here. Negative, 3 times 9. All right, hang on. Okay, 3 times 9 is 27. Thank you. I'll be here all week. All right. The derivative is 36. It's minus. So I got the same derivative. I did it whether he wrote and I took the derivative. Okay, guys. Here's question 9. And you just got to know your trig derivatives. All right, and the one that we're looking at here is cotangent. And we know that the derivative of cotangent is negative secant squared. So we just write negative secant squared. if you wanted to simplify that, negative times negative is positive, and so it would be 4 cosecant squared. Okay. Okay, great. All right, so that was our first little section. Now we're moving on to, all right, a couple of things that you want to remember. So let's talk about this. Limit, definition of the derivative, alternate form of the limit. Okay. Now, I know that this is going to be huge, but good. We know that the derivative of this is 2x. Like we know that, okay? We know the derivative of this is 2x minus 2, and that when we plug it in to find the answer at 3, it's going to be 2 times minus 2, which is 6 minus 2. I know the answers are, those answers are going to get you all 0 points. If you don't do it, okay, then do it. Okay, so limit definition. Here's the limit definition. That's right. It's 8, 0, f of x plus 8 minus f of x h. Okay, you guys want to remember that every test has some um, review, like spiral questions on it. And since we're only on Unit 2, the only place to get questions from is Unit 1. There's going to be some limits. Okay, and this actually was a, so, all right, and then we have the alternate form, which goes like limit as x of a, f of x, f of a over x minus a. This only works when you are given a point at which to find the derivative at. The other one works when you are not given a point where to find it. Okay? So these are the two that you want to know. All right, so for number 10, we're finding the derivative of this the super long way, right? Is very exciting. Okay, and the super long way is this. Limit as a, oh, actually first, let me write what f of x plus h is, right? If this is f of x, and x is right here, it's f of x plus h. Well, I put x plus h right here, okay? You're just plugging in x plus h in for x. So I get f of x plus h minus, put this in parentheses, f of x over h. Now, something that people very often points on with this question is they drop this. You have to write that on every single step until you get to the step where you are plugging in h is 0. You got to just keep writing. Okay, now, x plus h squared, if you guys forget how to do that, just write it over here. Okay, we FOIL it. It's x squared plus xh plus xh plus h squared. X squared is 2xh. Okay, so that's what this, and I have a plus 1. And then when I distribute this negative, I get minus x squared minus 1 over h. Okay? Now, I always start from the back because those are the things that cancel out. That minus 1 cancels out the plus 1. Minus x squared cancels out the positive x squared. I get 2xh plus h squared over h. Now, at this point, you have one of two choices. You can either factor an h out of the top, okay? Or, if it makes sense to you, you can, go ahead, all right? Now, if I cancel an h out of everything, all right, I'm going to end up with 2x plus h. And on this last step, is where I can then plug it in. So I get x plus 0, which is 2x, which is exactly what I knew, but I had to solve it that way. Okay, at least one. All right, now let's look at alternate. So for number 11, looking for, I'll just put, trying to find f prime of 3. All right, so f of x is x squared minus 2x, and the other thing we need is f of 3, which is 3 squared minus 2 times 3, so you just plug the point in. 9 minus 6 is 3, okay? Go like this. Limit as x approaches 3, because it's x approaches a, and in this case, a is 3. That's going to be f of 3 then, okay? F of x minus f of 3 over x. Okay, so look at the different parts. F of x is right there. F of 3 is right there. I found that over x. Okay? Now what happens when I try to plug in 3? Because we know with numerical limits, the first thing we do is we try to plug it in. What happens? Well, I get 9 minus 6 minus 3, which is 0, over 3 minus 3, which is 0. I get 0 over 0. We know that means that we have to do something, usually factoring. So I'm going to go ahead and factor. Still going to write x3. But on the top, I go, what multiplies to make 3? The only thing is 3 and 1. Make negative 2 minus 3 plus 1. Okay? And you can see that x minus 3. So this is the limit as x approaches 3 of x plus 1. And at that point is where you're allowed to plug this in. So it equals 3 plus 1, which is 4. And guess what? I already knew that the answer was going to be 4. I just had to. Okay? All right, now there's a few other important questions right here. Second derivative, so we need to talk about how to do the second derivative. Okay? And then equation of tangent line. That's obviously important. You guys want to make sure that you know that equation of tangent line, we do y minus y1 and x minus x1. Okay, and just as a reminder, x1 is almost always given to us. Y1 is sometimes given, and if not, log the x coordinate into the original equation. M is never given to you, and for that, you always find by plugging x into derivative. Okay, so that's how I'm going to do those equation of tangent lines. But first, let's go ahead and do this second derivative. Right? It says y is 1 over x squared is 1. Okay, now, both of these, I mean, I guess you could do quotient rule. That's really not the way, especially because you don't have any terms on up. This is actually just x to the negative 2. And when I move this up, what I want you guys to remember is I'm only moving up the x. I'm not moving up the 1/2. The 1/2 stays there and it becomes x to the negative. Now we can do a couple derivatives. 8. The first derivative is negative 2x to the negative 3 and negative 1/2 x to the negative 2. That's the first derivative. And the second derivative is positive 6x to the negative 4 and then positive 1x to the negative 3. Okay? Now, if you want, you can rewrite this as 6 over x to the 4th and 1 over x to the. All right, since that's kind of how the original one was written, write it like that. All right, go ahead and talk about equations of tangent. 3ex equals x, and we want the equation of tangent line of x. Okay, we know it's going to be y minus y1 mx x, right? We're going to fill this in one thing at a time. Well, first of all, the x coordinate is 0. That was given to me. The y coordinate I can find out by plugging in 0 into this equation. That's going to give me 3e to the 0 secant of 0. Okay. We know anything to the 0 is 1. Then as far as secant of 0, guys, need your best friend chart for that. But basically at 0, we know it's the point 1, 0. So we know line is 1. So f of 0 is 3. And that's what I'm going to put here. Okay? Now we need to do the derivative. All right, now first of all, this is going to be a product. Okay? It's going to be a product rule. And I'm going to go derivative of the first. Now, the derivative of 3e to the x is 3e to the x times the second. Okay, and then I go first, which is 3e to the x, times derivative of the second. You need to know what derivative of secant is. Derivative of secant is secant tangent. Okay? And so again, at this same point, at 0, it's 3e to the 0 secant. Then it's 3e to the 0 secant 0 times tangent. Right? We already know what secant of 0 is. Let's figure out what tangent of 0 is. Well, we know tangent is sine over cosine, and sine is 0 at that point, cosine's 1. So 0 divided by 1 is 0. Okay, so let's figure out all this. 3 times 1 times 1 plus 3 times 1 times 1 times 0. So the derivative at 0 is 3 plus 0. Okay, that's my slope. And now, all right. Now, as a multiple choice question, light chance, I guess, out and go y minus 3x, add the 3 over, y is x. Like, that's possible on a multiple choice question. But if you're just writing it out, we want, yeah, just as the first equation. Okay? All right, perfect. Okay, for number 14, the equation is for ln of x on x. All right. So again, right when I start, y minus y1 equals mx minus x1. And I already know what x1 is, okay? It's okay, cool. So let's go. Let's find f of e squared. So I'm taking this and I'm plugging it in here, right? Well, this is 4 ln of squared. You have to know some properties of logarithms in order to do that. The first property of logarithms is that exponents in the front are allowed to come down like that. So it makes 2 ln of e. And the other thing you need to know is that the ln of e is 1. So this is just 8, okay? That goes here. Now, for my derivative, constants in front stay in front, so the 4 is going to stay there. And then what's the derivative of ln? Well, we know that that's 1 over x. And when I plug in e squared, I basically just get 4 over e squared. There's really no other way to write that. But right here, I put 4 over e squared. That's fine. Okay. All right. And then lastly, number 50, we have x sine x at the point pi 0. All right, perfect. Pi x sine x by 0. Okay, so you guys, this time it gave me x1 and y1, right? It told me x1 is pi, y1 is 0. That was very nice. I just need to find the derivative. Well, I have to do a product rule, okay? Derivative of the first second plus first time derivative of the second, okay? Now at pi, it needs to be, so it'll be sine pi plus pi cosine pi. I need to know what that is. All right. Pi is over here. That's the point negative 1, 0. It goes cosine sine. So sine of pi is 0. Cosine of pi is negative 1. So this equals negative. That's what I put right there. And I'm done. All right. Okay. So hopefully that all makes sense. Now, in the next video, I'm going to basically start with number 16 and go through the rest. Okay? All right? Hope that all made sense, guys.